Hello, my name is Thilo Michael from the Quality and Usability Lab from the Technische Universität Berlin in Germany. And now I'm going to showcase you Retico, which is an incremental framework for spoken dialogue systems. So let me give you a brief overview. Retico is a Python framework to create spoken dialogue systems and spoken interactive systems in general. It implements the concepts of incremental processing, has a simple API to connect networks of modules, has a graphical user interface that runs in the browser, and is documented and the code is extendable. The whole package is available open source on GitHub. First, let me give you a quick introduction into incremental processing. Usually, dialogue systems are structured in a pipeline fashion, where there are different modules connected together and each module has a separate task. For example, a speech recognition module recognizes speech and transforms it into text and then forwards a whole sentence to another module, for example, a natural language understanding module, which then tries to extract meaning from that. In this type of system, each module processes a whole input sequence, for example, a complete sentence, before forwarding the information to the next module. However, this is very inefficient because the modules need the information from the preceding module to get to work. Incremental processing is a concept described by Schlangen and Skanse in 2011 that describes a concept where information is transmitted as small increments called incremental units. So each module does not wait until the whole input is complete to forward the information, but rather forwards small increments and hypotheses. Let me give you a quick example. In this case, on the bottom we have an automatic speech recognition and at the top we have a natural language understanding unit. Here we can see that the automatic speech recognition updates only the information that has changed to the last step. And we can also see that the natural language understanding unit is able to create predictions and hypotheses from the unfinished data and later revise those predictions to make them more accurate. This way, modules later on in the pipeline can create early hypotheses and start processing earlier. Retico provides an environment for incremental networks and provides interfaces with which modules can interact. It has already built-in modules for handling basic audio and text processing, and it also comes with several state-of-the-art modules like Rasa natural language understanding and Google's speech synthesis and speech recognition. Now I will give you an overview over the Retico API and the graphical user interface, and I will also showcase two services that are built with Retico. One is a translation service and the other one is a simple spoken dialogue system. Let me show you the Retico API. Here I've imported three modules. The microphone module that is able to collect information from a microphone, the Google ASR module that takes in speech and transforms it into text by using the Google ASR API, and a callback module that lets me output any information I want. So first I create the modules. Here I created a microphone module with a buffer of 5,000 bytes. Now I'm going to create the speech recognition module. Next, I'm going to create the callback that just prints out whatever it is receiving. Now that we set up the three modules, it's time to connect them. First, let me connect the output of the microphone to the input of the automatic speech recognition module. Next, I'm going to connect the output of the speech recognition to the callback module. And lastly, I call run on all the modules so that they start working. With this input statement, the program waits until I press a key, and after that, let's stop all the modules. And those are the basic blocks on how to build networks with the Retico API. If I now run this Python script, we can see that the microphone starts working, the Google ASR transcribes everything I say, and the callback module outputs the text. With this API, it is easy to create own modules and connect them with already existing ones. However, in larger networks, it can be difficult to maintain an overview over all the modules and connections. So there is a Retico graphical user interface with which you can create modules and connect them. This is the Retico graphical user interface, where you can place modules on a canvas and connect them. On the right, you can see all the modules that are available and can be placed on the canvas. On the bottom, you can see networks that were saved to a file and can be loaded. Let me quickly build a translation service. For the translation service, we need a microphone module, a speech recognition module, a translation module, a text-to-speech module, and a speaker module. Let me place them on the canvas. Now that I placed all the modules on the canvas, I can move them, resize them, and enable and disable them. Let me now arrange the modules. Now that I have arranged the modules the way I like them, I can connect them. For this, I can use the input and output buttons. Whenever I click a button, for example, if I take the output of the microphone module, the modules that can take the output of the microphone module as an input, I highlight it. So I connect the microphone module to the Google ASR module, and now I will connect the rest of the modules. And now we see the complete network. The microphone module takes its outputs and gives it to the Google ASR module, which recognizes German language. Then the text is forwarded to the translation module that transforms German text into English text. Then we have a ASR to TTS module here that transforms the incremental units from the translation to the speech synthesis. The speech synthesis itself takes in English text. And then we have an audio dispatching and streaming speaker module that take care of outputting the audio. When I now click Run, we can see that the module is translating everything I say. Viele Grüße aus Deutschland.
Greetings from Germany.
Let me now show you a simple spoken dialogue system. I already built this network, so I can use the load function of the graphical user interface to load the spoken dialogue system. As we can see here, the spoken dialogue system is very simple. It takes in the microphone input, uses Google ASR for speech recognition, it uses Rasa's NLU for natural language understanding, and passes the information to a dialog manager. This is just a simple rule-based dialog manager. This end of utterance module uses the information provided by Google ASR to determine the end of the utterance. The dialog manager outputs text, which is transformed into speech by Google TTS, and then again an audio dispatching and streaming speaker module take care of outputting the speech. If I now click Run, I can interact with the spoken dialogue system and ask it for restaurant information. Hello.
Hello, I can help you find a restaurant.
I'm searching for a cheap Italian restaurant.
Okay, where would you like to eat?
I would like to eat in the north of the town.
Okay, you want to eat cheap Italian food in the north of the town, correct?
Yes, that's correct.
I have the following restaurant for you, the generic restaurant at Main Street 123.
During the execution of the network, the graphic user interface shows information about the current status of each module. And as you could see, the information was processed incrementally. Because the graphical user interface uses the same API I showed you earlier, we can save this network to a file and then go into our Python editor, and there we can load this network. Now I have loaded all the modules and their connections into these Python objects, and I can iterate over them and start them. When I now run the script, I can interact with the spoken dialogue system. Hello.
Hello, I can help you find a restaurant.
This was a short overview over the Retico framework. Thank you for your attention. If you want to check out the GitHub repository, the link is on the screen, and if you have any questions, please feel free to ask me.